Hey guys, welcome to our course Finite Element Analysis using SolidWorks. In our previous video, we talked about how to perform a fatigue analysis on a component, and in this video, we will be performing a simple drop test of a PCB board. So now let's move on to the contents that we will be covering in this video. So the table of contents for this week are, first we will discuss on what exactly a drop test is, and then we will move on to the software part where I will just show you how to access the drop test panel in the SolidWorks simulation toolbar. Then we will be performing a simple drop test of the PCB board, and then we'll have a brief discussion of the results. Then we'll have a summary, and after that we'll be concluding the video. So the first topic is, what is a drop test? A drop test is a testing procedure that is used to check how rugged and resistant a component is to being dropped from a certain height. Most of us would have seen many YouTube videos where people actually compare 2 or 3 phones and drop them from a certain height and then evaluate how rugged a certain phone is based on how much damage the phone has suffered from the drop test. In the right here we have a simple drop test of a phone from a certain height, and this is performed in a SimScale software, and this is a drop test of a simple circuit board which was dropped from a height of around 2 meters. This was performed in SolidWorks simulation. So let's move on to the software part. Here I have our SolidWorks main page open. We will be performing the drop test of a PCB board. I've actually provided the link for that model which we will be analyzing here. The panel down below, you can access it. I'll just hit Ctrl O. Since it is a step file, not a solid part file, it'll just take some time to read the model and generate it into a solid model for us. Press OK. Alright, we have our model here. Let me just go quickly set it up for us. Okay. Since this is an assembly of many different components, it opened by default in the assembly panel. I'll just go over to SolidWorks add-ins and grab our simulation license. Okay, we have the simulation panel open. Let's just click it, and here let's press new study. This is the usual, it will just open the different simulation options that we have for ourselves. I'll just scroll down a little bit and go to specialized simulation. Here we'll see drop test. Just change the name to drop test PCB board and press the green tick icon. Okay, we have a model open in the simulation environment. So right off the bat, you can notice that the simulation options for performing a drop test is much different from what we do for a normal static analysis or a linear analysis. This is because the parameters that we use are much different from those kinds of analysis. There we need to fix a certain model, so we have a fixtures option, and then we need to apply a certain amount of load to it, for it loading module. So based upon the requirements, the options also change. Here we are not actually fixing the model nor giving any other external force. We're just taking the component up to a certain height and just then dropping it off on a certain surface. So first we'll just go and set material to our model. We'll give plastic, so press apply or edit material. We have the dialog box open. Scroll all the way down. Here we'll see custom materials. Under this we'll have the option called plastic. Here under this we'll have custom plastic. So that's the material that we will be applying. So give apply and close. You can notice that the color of the material has changed because I've given a default green color for that specific material in the properties. Here, and the rest of the components will just apply any metal to it. So again, press apply or edit material. We'll give alloy steel here. Hit apply and close. Okay, the color of these components is also changed. Our next course of action would be to mesh it. So let's go and hit create mesh. Here under mesh parameters, we need to do another thing. Give a curvature based mesh, because we have lots of small holes and lots of curves and bends in the model. So a curvature based mesh would give you a much better and more accurate results. We'll make it as 9 here, and the rest will just set automatically. Hit the green tick. Let the solver just mesh it. Okay, our model has been meshed. Next, we need to define the different parameters of the simulation. So for that, we need to go to setup, define or edit. Here in this option, we are defining the drop height and the velocity at which the object will impact. So we're not going to define the velocity, which is going to define the height at which the object is dropped. So under that, we have again two separate options. One is from centroid and the other one is from the lowest point. The main difference between these two is that the height whichever we give here, let's say for this here we have it as 1000 millimeters or 1 meter. So the distance it will take, the 1000 millimeter height, it will actually be taken from the centroid of this object and not anywhere else. And the lowest point, if we select this option, the 1000 millimeter will be from the lowest point which we define for dropping. And for our simulation, we'll just give it as from lowest point and 1000 millimeters. And then the next option would be to define the direction of gravity. Here you can notice that by default it is actually 9.81 meters per second square. This is actually the gravitational constant in Earth at sea level. If you want to change it, you can also change it. For example, if you want to test how well this object will get damaged when you drop it on the surface of Jupiter, you can just change the value to 24.8 meter per second square, and there you're dropping the object in Jupiter. So that's a bit of a good flexibility we have. Here we can change the value whichever we want. The next option is the target. This represents the ground or flow at which this object will be falling on. We have two options here. One is normal to gravity and the second option is parallel to the reference plane. So what do these two mean? So when you select this option, normal to gravity, the object will fall, the orientation of the target will be normal to the orientation of the plane whichever we have selected for gravity. For example, here we have not selected any plane for gravity. Let's go ahead and do that. Let me quickly open the design tree. Here you can see that I've created a separate plane here. So we'll be selecting this plane as our gravity, this plane as our plane for gravity, and just collapse this one. And the next option will be going to normal to gravity. So what this does is our object, it will fall in this direction. This is actually denoted by the arrow mark here. Or you can choose a reference plane along which the object would fall. Here we're not actually doing that. We're just pressing on normal to gravity because I've already created a separate plane here along which I want my object to fall. So I'll just select normal to gravity. The next option here that we have is friction coefficient. By default we have it as 0. That means the object will be falling on a smooth surface. We could also make it rough by giving a certain friction coefficient to the surface. I'm not giving anything here because for now let's just keep it as 0. By default, the selection here is for a rigid target. If you don't want your target to be rigid, we can also make it flexible. Let's just go ahead and press that now. Here you can see that we have many more options here. The first one would be the normal stiffness of the object or the tangential stiffness, the mass density, the target thickness. By inputting these values, we can accurately shape the target as per our requirements. You can also change the units in which you want it to be. It's either SI, English IPS or metric system. So we'll just select rigid target and proceed on with that. The next option that we have is contact dampening. Contact dampening is normally considered for bodies that come into contact with each other during impact and have no interpenetration contact between them. Here the contact dampening is actually calculated as a viscous dampening force. For now in this simulation we're just giving contact dampening as 0, not changing its value. Now that we have set everything that's required, let's just go ahead and press the green tick. Okay. The next parameter we will be talking about is the result option. Here right click on the result options and press on define or edit. The result options in the property manager allows us to set the options for the output of the drop test analysis. The first one would be solution time after impact. The solution time after impact option is used to define the time period up to which the solver needs to perform the simulation after the drop impact. For example, here we are given the solution time after impact as 156.8 microseconds. That means that the solver will capture and solve whatever stress, forces or displaced in the model for about 156 microseconds after impact. Let's just reduce it to 100 because 156 will take a lot of time for us to simulate. And the next option we have are the save results. Under this again we have 4 different options. Here the first option is the save results starting from. So what this option does is that it instructs the program to start saving data from the moment at which the data is given. For example, here the default value is 0 microseconds. So what this does is it instructs the program to start saving the data from the moment of impact. We normally use this parameter after an initial study to specify the time window of interest based on the preliminary result. The next option is the number of plots. This option is used to set the number of plots that the program will save. After that we have the sensor list and also the number of graph steps per plot. We're not actually going to change any values around here. I'll just explain why that is in a few seconds. Let's just go ahead and press the green tick. Okay. The main reason here is because drop tests take a really long time to simulate. So when you actually define all these options, if you run the simulation with all these options activated, the entire duration of simulation will come around 8 hours. For 8 hours, the solver will run the program in the background. So the simulation will run for 8 hours. Because of that, we're not actually giving any options. I've already run the simulation beforehand, just before recording this video. So I'll just show that to you and explain the results. Then again, remember, you will be provided this model. If at all you want to try it yourself, you can download the model and do that yourself. So let's just go to the results which I've already performed. So these 2 are the ones. Let's click on drop test. Here we have 3 results. So the first one would be the stress, the displacement, and the amount of strain that is developed in the model. You can also go ahead and animate each one of those. Let's click on animate. Or you can also save it as an AVI file. Here select options. Here select on this drop down to decide on what type of compression algorithm you want to use. Let's press on full frames uncompressed and click on OK. Here you can decide how fast your simulation should run. You can either make it extremely fast by moving the bar to the extreme right, or you can make it extremely slow by moving it to the extreme left. We will set it at 125 and press on play. So it will just generate the frames. It will just create the frames and run the simulation for us. Here it is. You can see the type of deformation and where the strain actually occurs. You can also pause it at a certain instant. Look around and again play. You can do the same thing for all 3 options, the displacement and the strain. Well, that's it for the software part, guys. Let's move on to the summary. So in the beginning of the video, we had a brief discussion on what exactly a drop test means and where it is used. And then we performed a drop test of a PCB board in SolidWorks simulation. And then I explained you how to interpret the results. Well, that's it for this video. Hope you understood how to perform a drop test in SolidWorks simulation. I'll meet you again in the next one.